In this video, I will demonstrate the capabilities of the decontamination inspector, which is the tool that I use for inspecting the output of the SEER spectra decontamination module. I've already loaded 4 exposures and location tables and the output from the module. If I hadn't already done that, I would either have to load each one here, also the grism sensitivities, or I would have had to load a previously saved session. Okay. Also note, this box down here is not part of the program. This is only telling you the keys that I'm pressing. So if I press N, you can see N. If I press escape, you can see escape. Okay, having said that, the most basic features of this program is it lets you see the dithers, each detector of each dither. You can just easily look at it. You can just select which of the 64 you're interested in, and it automatically scales the brightness so that it looks nice. Okay, one step up, this is a bit like DS9. You can use your mouse cursor here with this info window to see the X and Y coordinates of the cursor, the RA and DEC according to the information in the header of the FITS file, the value of the pixel under the cursor, and there's some other information about the exposure here. If you want to look at all of the information, it's in the header. You click this and you can browse through all the details. Okay, so one feature of this is that I can show the bounding boxes of all these galaxies and stars, and so I click on one and then I can right click and I have a menu. So I could show all the contaminants for this guy. I could show an object info window, open a tab. I could show this in all detectors. Then I can do plots. So I will first show the contaminants for this object. Okay. So if I click on one of these contaminants, oh, by the way, 0th orders aren't highlighted, only the first orders. So these are the contaminants for that particular object, and I can then go and inspect them. Okay. I can look at the object in all other detectors. So there's 4 dithers, so it could potentially be in all of them. Let's see. Yes, it's in all of them. In dither 2, it is here. In dither 4, it is here. In dither 3, it is here. Close these. Okay. I can show information about this object. This is the ID number. I can copy that if I need to. This object is a galaxy according to the input files. Here is the JNH magnitude, this color, RA and DEC, this position angle on the sky, the major axis and minor axis, shape parameters. There's another window which I'll go over later, so I've chosen a specific source I want to look at. You can look at plotting the rows and columns. So this is the sum of all the columns, the sum of all the rows. You can see the profile. Okay, so to look at more of these plots, I'm going to choose a specific object. If you know the ID number of a specific object, you can put it here and search for it, and there it is. So now I want to open this, open all layers, show all layers. So up here we have the original spectrum. But just the original cutout. This is the model of the contamination for this object. This is the decontaminated spectrum, so the original minus the contamination gives you this. This is a model of the spectrum of the object based on the, well, it should be based on the shape of it, but it's not. It will eventually be based on the shape, but it's based on the J and H band fluxes and just some generic shape. This is the residual. If you take the original minus the contamination minus the model, this is what's left over. If everything is done perfectly, this should be noise. And this is the variance of the decontaminated image. These regions are regions where there are 0th order contaminants, which we just flag. And this is the 0th orders, just explicitly shown. Okay. I skipped over this before. We can now open this object tab, and we see that this particular object is available in, or it appears in detector 1 of dither 1, detector 1 of dither 2, and detector 1 of dither 3. So I could make a plot of these. I can choose what to plot. I can plot the original flux, the contamination flux, which is a flux of the contaminants, the decontaminated flux, and the model spectrum. I can, on the y-axis, I can either show the raw data in the pixels or plot the calibrated data in physical units. And on the x-axis, I can either use the pixel position or the wavelength according to the location tables. So I'll make the plots. Here they are. The gray is the original. You see that the green is the contamination, and then this you subtract. So this minus this gives you that, and the model agrees rather well with the decontaminated spectrum in all of these cases, all 3 cases. So we're going to look at some other features, looking at this one. These plots are generated by matplotlib. So we have the standard adjustment tools. You can zoom in with this. You can go back to the previous view like that. You can adjust things by setting type, layout, adjust things like this. So basic adjustments. You can also go in and adjust the properties of the axis and details about the curves. So you get the line width and everything. Make simple adjustments like this. And I've added another feature where we can go in and get more information. We can add things to the plot or get information about what's in there. So here's some examples. I could, for instance, add a vertical X-span, so something right here. There we go. I can list everything, all the data series that exist in there, like this. So these are listed in the lines of the axis. 0 is the original spectrum, 1 is the contamination, 2 is the decontaminated spectrum. Okay, we're going to look at that. We can get the X and Y. We can get the X and Y vectors that are being plotted here, like that. And now x values. We can then, we can do things like we could plot something. So I'll smooth the data, use the median filter from SciPy signal. This is a median filter, so a smoothing box is 21 pixels wide, or 21 elements wide. And here we go. And now we can plot axis plot x smooth color equals that. And there we have it. And we can also save data. We could just open a file, but this is the numerical Python way of saving files. So I just save it as a generic file name, and now it's saved to disk. Okay. So that pretty much sums up the functionality.